have any query regarding previous two lectures, because these are the just basic things. And if you have query, you can raise the concern in the group or concern in that class. So today I'm just preparing a one basic simulation report for the PVsyst. So yesterday we have just started one PVsyst report. I just start a new project, like here, clicking on that, just mentioning the 13 class PVsyst, PVsyst simulation report. Okay. Now we just make some like area, like we go to the Google Map and check any specific or general area from that side, like because we are just preparing one ground mounted system like that. So if we start like that here, so just we are preparing just this in the Lahore, Pakistan. This is the area in the Saqib town area. We just mentioning this coordinate system in our PVC simulation report. Okay, just go to that new site. Okay, new site. Search the locality. Search locality. Okay, now search that value. You can see that it is mentioned that this is the location where this is the area available. Now accept this selected point. They will automatically get the name from the side, like Babu Shiragav Shah, Pakistan. If you want to change the side name, you can do that. Like you just click on that and you should change the site locations. We have these information weather data files. For the PV NASA file, please import the monthly data from the Meteonom NASA, like this thing. Sorry. Hmm. But if you want to use that solar GIS file, solar JTMV file, so you have to import and you have to purchase that data. But the automatic data is available. Like if we want to NASA, this will import global temperature value from the NASA database. This is not always the best data source, especially in the mountain regions, but it covers the whole world cells. Like basically, this is the satellite based data. Okay, okay, okay. What is the reason? Again, go there and search again their locations. Accept this point. So we have these data like this solar cost TMV file, NREL, these PVGIS TMV file. These we have to like purchase, like solar GIS TMV file. We have to purchase that data. But this NASA and Meteonom, you can use that one. Automatically, they will get from the database of the PVsyst. So Meteonom is the reliable database. Meteonom. If you have the solar GIS TMV file, that's very good. But if you don't have that, you should use that Meteonom file. Import that file. Click on that kilowatt watt hour per meter square per day. Okay, save it. Again, save it. Yes, you want to save that. Save that. Okay. Now your file is available. Now you just save that file. Okay. So again, you have to like project setting, go into the project setting, albedo setting. We have seen that our area is like grassy area, grassy. Okay. Now they have mentioned that the urban situation grass level. You can see that grass level is around 0.15 to 0.25. But our grass like that, they have the range. So we just use the in between values like 0.20. Okay, default value. We use that value. But most of the time, like the international client will give you the albedo studies. Albedo studies. If you want to go into the detail of that albedo, what is that albedo? Basically, I have explained, but if you want to go into the detail of that albedo, you just click on that question marks and they will explain everything in detail. The albedo coefficient is the fraction of the global incident irradiations reflected by the ground in front of a tilted panels. In front of a tilted panel. The albedo coefficient is the fraction of the global incident irradiation reflected by the ground in front of tilted panels. This effect takes place during the transposition computations of the horizontal irradiance onto the tilted panels. So this is basically the formula how we will calculate like albedo. 1 minus cos I divided by 2, where I is the plane tilt. See, for example, Hay model, like this means 0 for the horizontal, 0.5 for the vertical, 0.067 for a 30 plane, like this type. In this project definition, the albedo value can be adjusted even each month in order to take any possible snow cover into the concentration. Admitted urban locality is of the order of 0.42 and can go till 0.4 the snow cover that like this type. They have mentioned that you can like everything they have mentioned like the grid inverter, anything other than they have just explained in that one. You just go there and you can read out these things. Okay. So that is why I have selected that one. Now, design condition, you have to select the lowest temperature for the absolute value, which I have explained in the first class, I think. When we have study how we will calculate the number of PV modules per strings, number of PV modules per string, in which you have seen that we have to know about the VOC of the PV module panels, the temperature, lowest temperature of that side, lowest temperature of that side, then you can calculate the PV module string sizes, maximum number of PV module you can connect in the series. You can just calculate that one. So on that basis, because we don't have any weather data where we can analyze that how much is the maximum lowest temperature which will go in that side. But as of now, if you want to like just check how we will calculate, how we will uh, check that things, you just sel- go into the Google for understanding purpose. Search that Sakib Town, Lahore, Lahore, weather, the spark. So they have Lahore climates, like weather spark, which is online website. They have give us the data regarding the temperature, rain, and other things. If you have exact side name, then it's very good. But if you have like near to that one, like we have the Lahore climate. So the Saqib town is available in that Lahore area. So you just click on that Lahore climates, go down every temperature in Lahore. You can see that they have mentioned that the highest temperature, June 19, Feb 20, 27, 34, 38, 39, 36, 34, 34, 31, 26, 21. Temperature, this is basically the average temperature, and the lowest one, you can see that it around 8, 9 degrees centigrade. It is the lowest temperature. But most of the time, they will go down, like, go down there. Like these days in Pakistan, it is very cold days. And we have seen that it is go around 6 or 5 degrees centigrade. But the issue is that we have to analyze that uh, the temperature will be effective one when we get the irradiance value should be higher than 100 watt per square. Like I have explained in the previous class when we are doing the string sizing, and I have shown you how we'll see that the irradiance value, and then we will check again that the temperature with respect to that irradiance. So when like in the night time, you have seen that maybe temperature will go to the 0 degree centigrade or 2 degree centigrade. But at that time, the radius should be zero. So the inverter should be not getting the power from the solar side. But in daytime, they will getting the light and they will convert into the DC AC power. So at that time, temperature is very effective one. So in that side, it is mentioning that it is should be around 8, 9 degrees centigrade. 8, 9 degrees centigrade. We are not going to that actual value. We just mentioning it as a 5 degree centigrade. Like we have just 5 degree or 4 degree. Just we put that 4 degree centigrade as the lowest temperature. Okay. And just click OK. Other limitation are not very important. Save that one. Now you have this varied options. You just mention the varied options. Like I have a 13 class basic simulation report. Oh, okay. Then we go to the orientation option. Now you have different options. Like we have fixed tilt options, several orientations options. Then you have unlimited seasonal tilt angle. Seasonal means that summertime different and the uh, winter time different angles. Then you have unlimited sunshades, like in that way. Then unlimited trackers options there. Horizontal axis trackers, like this type of the thing. Tracking fixed tilt. Okay. Like unlimited shades available there. So we are not doing the shadow analysis. If we are not doing the proper shadow analysis, we just use that unlimited shades. You can use the now the fixed tilt options like the several orientations and this fixed tilt orientation. It will be used in case of rooftop structures, because in the rooftop structure you have seen that most of our installer will install some panel in the south direction, some will be to meet the capacity, they will install some at some azimuth angle. So we have different orientation available there. But if you don't have any specific like one orientation, like they have zero azimuth and 20-degree tilt angle and 4-degree tilt angle, 5-degree tilt angle, then you have to go to the that options. But if you have any option of the customized structure, like we have the raised one main shed type structure, then you should use fixed tilt option. But here, which I have selected the location, we are installing just a simple ground mounted systems. We have just pitch of 10 meter, tilt angle of 25-degree. Then you have just selected that option, like 25-degree tilt angle and azimuth zero. Shed should be like 10 or 15, like we have just random options available. 10-meter pitch available. This column band width, basically this red to red options. This red dot to the red option means that the total width of the panel, like we have, if we are installing the 2 PV module in the portrait option, then you have to add the uh, uh, total length of the one PV module multiply with the two options, because two PV module installing two P structures available, and the spacing between that two PV modules. So here we are just installing like two P structure, and we if we have uh, 232, if we have the length of the one PV module is 2382 mm, we are installing the two PV module in one row, like this type of structure, and we are give, giving the 26 mm distance between the two PV modules spacing. So it becomes 4.79. So we are just putting here the column width 4.8 meter. Okay. Now this is the top inductive inactive bands and bottom, means that we have to increase like the purlin of the PV modules. So you have to put that column bandwidth like this type of. Then if you want to use the electrical option, like we have to specify the partition of the PV module, partition of the PV modules, because you have seen that our PV modules are half cut. They have just one PV module divided into the two faces. So we have to like total width should be divided into the four options. Okay. Then you have to click OK. Please define the system, because they will give you the red options. So here we have just two options. One is option that we just put that our plan DC capacity, or we just use the number of string as per our system requirement. So we are just preparing a 100 megawatt system. 100 megawatt system. 100 megawatt means that it should be like in kilowatt. 100 multiply with the 1000, so it become 10k kilowatt systems. Okay. And we are selecting the PV module like JA solar, like JA solar. We have selected the JA solar, and the PV module should be like 715 watt. Okay. Then we have the Huawei inverter, and we have selected like 300 kilowatt H1 options are 275 kilowatt inverter available there. We just selected that options. Now we have to select the ratio, like it almost if we don't have to maintain the grid limitations, then we have to go in between like 1.1 to 1.2 P norm ratio. But if you have to need the grid code compliance through the inverters, then you have almost 1:1 ratio, like DC and AC capacity inverter level should be like the same one. So we considering that we have to meet the KVR, a reactive power requirement of the grid through the inverter. So we have just selected that to the 1 ratio. So we are increasing that value, the number of inverters. Okay. Now we should increase to the like you can see that we have installed the 350 inverters. Install the 360, 352. So we have increased our power to the 96.8 kilowatt AC power. So 96.8 megawatt is the AC capacity and 100 megawatt is the DC capacity. String size should be like 14 to 29 because it inverter is 1500-volt inverter. If it should be the 1000-volt inverters, like the small power inverters, it should be the cable, the string size should be like 19, 20, maximum by 20. So here we can connect the 28 or 29 in PV modules in one string. We have just selected the 28 PV modules in one strings, and total 4995 is the string sizing. So we have just selected OK. Then we go to the detail losses. It is because I have explained that it is the free moving air because it is the ground mount systems. We just select this option. Now we go to the that losses. If we go into that STC losses, so we have to calculate that losses. We have to analyze the voltage drop or power losses at DC level. So here we have to like check that losses, but I don't have that at that time calculation, proper calculation. But as per my experience, we just have to put that losses up to the 0.9 or 1 degrees, 1 percentage. So I'm just putting the 1 percentage value. Here is the AC losses. AC loss is between the whole systems. If we select that aluminum wires and we just select that option, it is around we can say that it around 1.5%. In the AC options, we have to like use the up to the 1.5. Like the 320 or 330 meter cable is maximum cable. So I have just selected that one. Now, because we are using the 100 megawatt system, it should be like we are using the MV transformer and HV transformer. So we have selected uh, the 16 number of MV transformer there, and the MV voltage is 33 kV. We have just selected that our MV inverter will step up from 0.8 to 33 through that MV transformer, and then we will transformer step up that 33 to the 132 kV. We are analyzing the power for PVC simulation for the 100 megawatt system. Just we have to connect with the grid systems. So here we just on the average basis, we when we are doing the proper sizing, like we are preparing the layout and then we have analyzed that proper length is okay. But at that time we just giving these average basis like the 2000 meter. But aluminium cable, it should be the aluminium cables and the size should be like 240. It should be 3000. Okay, cable should be like 185. So that MB loss should be like 0.29 or 0.3 or 35. this is the average loss we just achieve for the large scale projects. Now we have to put that transformer losses in your simulations. So the nominal power for that transformer is like 6.050. I will show you in the data sheet by tomorrow class, inshallah, in the Huawei. Then the iron and copper losses. We have to put these losses. When we are dealing with the manufacturer of that transformer, they will give us that values. We don't have any and then specific value, but it is as per the vendor provided values. So most of the time for the aluminum windings, we have seen that this value should be 0.1%. So 0.1% means that total MVA is 0.6050. Here is the 0.1% means it become 0.00 MVA. Okay, and this copper loss should be 1%. Copper loss should be 1%. So it become 1 divided with. uh, so it become like this is. Okay. Now they have automatically calculated that efficiency of the P norm values. Then we have to use that HV transformer. Here is the voltage is 132 kV. The transformer length injection point, like where we have to measure our PR, it around like 100 meters, not more than 100, 200 meters more than that. They are not like that one, like 400 cable we have just selected. And transformer 132 grid, and then the nominal power, like we have 100 megawatt, we just like select the 120 MVA transformer. Okay. For the HV transformer, we have seen that these losses should be like 0.8% for 0.8% the iron loss, 0.8%. No, no, no. Sorry. 0.08. 0.08. 0.08% is the iron loss. So I'm just putting that value. And this value should be 0.4%. 0.4%. 0.4%. When you are doing that proper sizing, you have to get these value from your vendors. But as per our vendors, these are the values we just get from the vendors. Now we go to the module quality. I've just explained that these module efficiency, because we are getting the 5 watt, mm, which I have shown you the modules. 5 watt is the power tolerance. So 5 divided by 715, it become 0.7%. 0.7% is the gain value. But 0.7 is more conservative because all the PV module don't have that value, like 5% 5 watt margin. So that is why in that case, the negative means that it should be the gain. If it is its value is positive, then it means that it should be the loss. So here is the gain. So we have to decrease that value. Like we have put that 0.4 or 0.5%. Like we have put that 0.5% because all the PV module don't have 5 watt margin tolerance. Then this LID loss, we have 0.6, like I have explained that one in the previous lecture. This mismatch calculation is very important. Mismatch calculation is very important. So just go into the detail computations. We have these values. We have these values. PV modules are PV cells. We have selected these are in the parallel. Like we have selected like 14 or 20 strings chain in the parallel. Okay. Now you have to select this RMS value. Okay. Or we have to put that standard value, standard deviations. If we go into the details, so if we get the RMS value from the vendor, they will provide that RMS value. Like they are giving you the change in the flash test reports or in the changes in that value. Because if you get like a 32 batch, 32 panel in one caret, all the PV modules don't have the same value of the IEC VOC. There are the some margin in that values. The standard test conditions margin, they are like deviation, uh, deviating from that values. Like I will show you one dry flash test report. Show you. So here you can see that this is one batch. Like I have pallet one. Here is the IEC 80 17.88. Like you can see that there are the some margin there. 17.686461. Like they are basically deviating from each other one by one batches. So you have to calculate that standard deviations of that flash test reports. And then you have to put uh, the average of that one. Okay. Like we have calculated that standard deviation. Standard deviation. And then you have to calculate the average of that values. It is a flash test report of our previous projects. So this is divided standard deviation divided by this value. So this is the basically small values in the percentage, like 0.15%. So like the same one, we have to calculate the VOC, like same one. So this RMS value, when we put that 5%, we have put that 0.15%, or like we have put that 0.15%. And show graph, recalculate. You can see that their power loss at MBPT is 0. But it is the one case. It is the flash test condition. But it is based on the previous project, because the same project, when we are doing the simulation, we don't have any flash test report, because the PV module are not like purchased one. They are purchased at the end of the project. So we have to, based on the previous project, we have to see that. And in also in the mismatch calculations, we have different factors, like the soiling options, the cable small losses of the small cable which is available in the PV module, and other things. So we have to calculate, or we have to put that value. If we just put the default value, we have 2%. But if we use the proper, like as per our experience base, we just put that 0.8 to 1%. 0.8 to 1%. And this is the string voltage mismatch. It should be calculated based on the value of the lowest string size, which have the like one string has 20-meter length and the other has which these strings are connected at one inverter. It has like 100-meter length. So we have different values. So we have to put there and calculate the mismatch loss. You can also detail study they are available. Like we have one string of the 100 meters and they compare with that one. When we calculate that one value, okay, you can see that the mismatch string voltage should be voltage and in percentage is should be 0.05%. But here we have just margin there. So we just put 0.2 percentage as per our experience based. Then we go to the soiling options. Soiling, like as per the site condition in Lahore, there are the dusty areas there. So we just put 3%. We don't, because in the soiling case, only 1%, one software is available, which is PV Radar, which is very expensive one. Our company is not purchasing that software. Some like higher EPC company will purchase that one, but they are too much higher price. So we have to like it is should be the based on the experience based, not a proper calculation for the soilings. Then IME loss, then auxiliary. In the large scale project, we have just auxiliary systems. Like we have the operation O&M buildings. There are the multiple SCADA systems, lights, and other things. So we have to just put that auxiliary value. We just yeah, in as a example, we just put 150 kilowatt. And for the inverter, we have threshold like 4 watt. No, this one, not this one, this one. For the proportional inverter, they have just 4 or 3.5 watt per kilowatt for their internal working, like they have used it, that one. Then we have AJIC tool, they are available. So like for the 1 year, for the 30-year graph, we will show. And then we have unavailability system, when our system will be unavailable. Like we percentage, like mostly client will uh, say to you, use just 1%, but it should be in the daytime, like we have like this random time. Okay, P type no. P four seven. This is two, because we have to select as a like daytime. Okay, then we have to simulate that our simulation. So here you can see the report options. We will explore more the things in our next classes, inshallah. You can see that it is the other things available like PR value, specific yield, and the inverters and their string sizing, IME loss, and other things. So that is for the today. Tomorrow, inshallah, we will explain more like the shading analysis, best systems with that one. And in the last class, inshallah, we will do for the uh, standalone systems and other things. We'll add more details in that one. And we will see and read that details calculation study, inshallah. That is for the today. Inshallah, we will continue from that in the tomorrow class, inshallah. Okay. If you have any questions, you can ask. We have just 5 minutes, then we will end up our class.
Sir, I have a question regarding transformer ratings and that how we calculate. Uh, can't properly understand that section transformer.
Basically, Mr. Ahad, when we are working in large scale projects like 100 megawatt, 200 megawatt, we have different teams there available. And we have to follow the IC standards. If we follow the IC standard, the transformer rating should be higher than the 20 to 25% extra margin there. But most of the times, client will give you the proper sizing of one transformer. But if we do proper sizing of the transformer and other like parameters in the transformer sizing, uh, because as of my experience, I am just working up to the 33 kV, higher than 33 kV. Another team will working on that, and they are properly doing the transformer sizing for the 132 kV transformer power transformer. But in the 33 kV transformer, most of the vendor will give you the containerized solutions in which they have properly sized uh, 66 or 600 megawatt MVA, sorry, MV transformers, and with the LV switch built in. They have proper their calculations on the basis of their ratings, their derating factors, their environmental factor, because the transformer also have their derating options like environmental options, their temperature options. So we have to derate that values of the transformer. I will check again if I have available any derating and calculation of that transformer. I will share in the groups. But as of now, I uh, don't have any proper calculation example, and I don't form any proper calculation of the transformer because I am just working in the layout and cabling and other things. Uh, for that one, our team have different team for that calculations option. But as a basic value, we just follow the IC standard 60076, in which they have clearly mentioned that your transformer rating should be higher than 20 to 25% extra.
Okay, sir.
Okay. If I have just any vendor calculations, I will share in the group, inshallah. I will try to find that values.
Sir, a prom ratio that you say, what impact can be happen in the grid if this ratio is not maintained properly?
Sorry, sorry.
The ratio
Acha,
prom
P-norm ratio.
phenom
P-norm ratio basically, Mr. Kazi, P-norm ratio is very important at that factor. Because when we are providing the reactive power compensation to the grid through the inverter, then mostly we have to give you the higher value of the AC power at the inverter level. Then they will uh, provide the VAR reactive power plus the active power at the grid point of connection. But if we provide the reactive power compensation through the capacitor bank and any other options, then their ratio will be lower, like 1.2, 1.15. But we have to uh, follow the LCOC, LCOC, lower cost operational cost is like that one. Because if you are the ratio in is on the higher side, then your cost will be on the lower side because your DC capacity should be higher and your AC capacity like equipment like inverter and they are in the lower side. The cabling will be lower. Okay, they are the some calculations.
Okay, sir.
Okay. Because if I go into the proper calculation, like we have different calculation for the VAR compensation, we have to like meet the grid requirements. We have to study the grid code compliance requirement of that grid, special grid, like in the South Africa ESCOM grids, and in the Pakistan the NTDC grids. Like in the Bangladesh have some grids available. They have their codes, and we have to follow that code, and you have to provide the the active power at when your voltage up and down, you have to provide one uh, one value of that active power. So you have to properly calculate, and you have to like perform the grid code compliance studies. Then you will decide what is the basically the best ratio. But as of now, as the experience based values, we have to like provide at grid value 20 to 20 sorry 15 to 20% extra AC capacity, then you meet the grid requirements.
That means we will have to add some 15% or 20% extra solar panel, right?
No, no, no. AC capacity and AC capacity at the grid level.
Okay, okay.
DC capacity means that at inverter level, like the ratio should be 1 or 0.98. This is the like when you are providing the 17% higher, your AC and DC ratio should be 1. But if you are providing the 20% higher, it should be like 0.98 AC DC ratio.
Okay, okay.
I will explain that things in the tomorrow class. So you will more confusion will be inshallah will be clear more. I will show some like a layout, and I will explain that point like the grid options.
Okay, sir.
Okay. Any other question, guys? Okay, guys. Inshallah, we will meet again by tomorrow class. Inshallah.